Today we're looking at notes M-1, pi over 4 multiples of the unit circle, and we will also be looking at pi over 3 and pi over 6 multiples of the unit circle. So there are various things you need to know or memorize about the unit circle. One of those things is the angle measures in degrees. The other thing is the angle measures in radians. And one more thing that we're going to be deriving today is the various coordinates that are created from the angle measures of the unit circle. And that's what we're going to derive today. You don't really need to memorize that portion, where we derive it, but you do need to memorize the coordinates themselves. So let's refresh a couple of things first. So on this unit circle here with our pi over 4 multiples, in other words, that's in radians. Pi over 4 multiples in radian angle measure, but if we're talking degree angle measure, remember pi over 4 is equivalent to 45 degrees. So this angle measure here is 45 degrees, which is equivalent to pi over 4, and each of these angles just adds 45 more degrees, or in other words, pi over 4 more radians. So this is your 45, this is 90, etc., etc., etc. in degrees. Now if we're talking radians, remember this is 0, this is pi over 4, this is 2 pi over 4, or simplifies to pi over 2, this is 3 pi over 4, this is 4 pi over 4, which simplifies to pi, which we know this right here is pi, radians. Okay, so I'm hoping you're noticing the pattern. The 1 pi over 4, the 2 pi over 4, the 3 pi over 4, the 4 pi over 4, the 5 pi over 4, 6 pi over 4, which simplifies to what we call it, 3 pi over 2. Then after 6, 7 pi over 4, 8 pi over 4, which obviously simplifies to that full revolution of 2 pi radians. So when we derive these coordinates here, the special ones, the corners here we already know, and we'll go back and discuss that in a minute. But these special coordinates here, when we derive them, we will be using the geometry knowledge of the 45 degree, 90 degree triangle. So we're talking degrees. So what I've done here to derive these special coordinates is I have drawn in a 45, 45, 90 triangle. So we know this is 45 degrees. We drop this down to create a 90 degree angle, which means this angle measure must be 45 degrees. So with this knowledge of the 45, 45, 90 triangles, we know that the sides are x, x, x square root of 2. What we do know from the unit circle is across from this 90 degree angle, this is a radius. Each radius is 1 unit long. So we know across from the 90 degree angle measure, we have a 1 unit side measure here. So since these are equivalent, we set x square root of 2 equal to 1. We know that that 90 degree angle has a side measure across from it of 1 unit. We set that equal to 1. We want to get x by itself so we can find out what these side measures are, the x side measures, the sides across from the 45 degrees. So we divide by square root of 2, to get x by itself. Then you get x equals 1 divided by square root of 2, but you know it's not allowable to keep that radical in the denominator, so you rationalize by multiplying by square root of 2 over square root of 2, which gives us that x equals square root of 2 times, here on the bottom, square root of 2 times square root of 2 is 2. So x equals square root of 2 over 2. So that tells us our side lengths for both this portion of the triangle and this portion of the triangle are both square root of 2 over 2 units long. That tells us our coordinate here at this point. So if from the origin this side length is square root of 2 over 2, then we go right square root of 2 over 2 units, and we go up square root of 2 over 2 units. You never need to remember this part again. You just need to remember this part. So at the angle measure of pi over 4 in radians, this coordinate is square root of 2 over 2, comma, square root of 2 over 2. Okay, because this triangle that's created here is exactly the same triangle, All right, you just think of this point as almost sliding over. So this coordinate here, since you're going left from the origin, will have an x value of instead negative square root of 2 over 2, but the y value is still positive, so square root of 2 over 2. And then this coordinate here is going to be negative square root of 2 over 2, because that x value is negative. And then for this coordinate, the y value is also negative. You go down from the origin. And then this point right here is going to have a positive x value, square root of 2 over 2, but its y value, since you're dropping down, will be negative square root of 2 over 2. And of course, you should remember that these coordinates here at 0, pi over 2, pi, and 3 pi over 2 are the easy ones. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so that's our pi over 4 multiples in radians, or in other words, our 45-degree angle measure. So now let's switch gears to our pi over 3 and pi over 6 multiples. So what I'm going to look at it really as is the pi over 6 multiples. So let's derive, before we even get to the coordinates, let's talk about the radian angle measures. So obviously this is 0 radians, and then each of these lines drawn in, if you're thinking in degrees, is 30 degrees. So this is 30, this is 60, this is 90. Keep on adding 30 degrees to get to the next, right? In other words, each of these is pi over 6 radians. Okay, pi over 6. So you keep adding pi over 6 to get to the next. So this is 0 radians. This is pi over 6. This is 2 pi over 6, which simplifies to pi over 3. This is 3 pi over 6, which, hey, what do you know, simplifies to pi over 2. This is 4 pi over 6, which simplifies to 2 pi over 3. This is 5 pi over 6. And last here, 6 pi over 6, which, yes, as we expected, that checkpoint of pi. And then 7 pi over 6, 8 pi over 6, that simplifies to 4 pi over 3. 9 pi over 6 simplifies. 10 pi over 6 simplifies. And 11 pi over 6 simplifies. So that's if you're looking at your pi over 6 multiples, each of these individual angle measures here. If you look at the graph in a different way, kind of try and cut out the every other one, then you're talking your 60 degrees. So this one here, 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 and then back to the beginning. Okay, those are the ones that ended up simplifying, as you probably noticed, to the pi something over 3, right? Each of those that simplified. Okay, so think about it in both ways. So that's for your angle measures. Now let's derive the coordinates for these special ones. I've already put in all of them, but remember, these are still the same. 0, 1, negative 1, 0, 0, negative 1, 1, 0. You already knew those. Okay, so now let's derive where these coordinates came from. These ones that are in between the ones we already knew. Okay, so remember, you know 30, 60, 90 degree triangles have side measures of x, x squared root of 3, 2x. So I've drawn in both of these triangles here and here. So first we're going to look at this 30, 60, 90 triangle. So we know that this measure right here across from the 90 degree is 1 unit long. So you know across from the 90 degree angle is 1 unit long. So therefore you set the 2x equal to 1. You divide by 2 to get x by itself, so you get x equals 1/2. So that tells us what the measure of the side across from the 30 degree angle is. So across from this 30 degree angle here, we have a side measure of 1/2. That gives us our y value. That's how far up we go for this coordinate here. Okay, to get the x value, how far right we go, this square root of 3 over 2, how we got that is because this side measure is across from the 60-degree angle. And for the 60-degree angle, we know we take the x value and we multiply it by square root of 3. So here we took the x value of a half, multiplied it by square root of 3, and we got square root of 3 over 2. So that tells us this side measure here, which gives us our x value because essentially that's how far right we go. Square root of 3 over 2 units. So then this triangle has the same angle measures, it's just placed in a different way. So we know that this side, because of the 30, 60, 90, we know that this side here is the square root of 3 over 2, the long side, right? And then we know that this side, how far right it goes, the small side from this triangle here, we know it's the 1/2 measure. So that gives us our x value. So just like you did for the pi over 4 multiples, for the pi over 3, pi over 6 multiples, you're going to just look at its equivalent point on the other side of the unit circle. So here, we'll start here. If this one's square root of 3 over 2, comma 1/2, then you know this point is going to be negative square root of 3 over 2, comma 1/2. And then you know this point here and this point here, okay, the reflection down, this is going to be your negative square root of 3 over 2, comma negative 1/2, because both the x and the y values are negative in this quadrant. And then this point here is going to still have a positive x value, same x value, goes the same distance to the right. You can see that probably pretty clearly. And then we go down 1/2 a unit. So that's those points. And then you look at these and you do the same thing. So obviously you know positive 1/2, comma square root of 3 over 2. So then this is going to be negative 1/2 because we go left 1/2 and then up square root of 3 over 2. And then you look at their equivalents down low here in quadrant 3 and quadrant 4. And you can see why this is still negative 1/2, comma, now we're going down square root of 3 over 2 units. And then this point here, we're looking at positive, so right 1/2, down square root of 3 over 2. So that is where we get the coordinates for the unit circle.